Hello, my name is Tainara Michelotti. I'm a master's student at the South Dakota State University, and I'll be presenting about difference in dry matter intake of primiparous and multiparous lactating dairy cows assessed through multiple on-cow accelerometer sensors. Beginning with a brief introduction, dry matter intake is a fundamental parameter in dairy nutrition and physiology. It can help us estimate individual milk efficiency and also to monitor herd health. Intake is essential for both research trials and commercial farms. However, there's a great challenge to estimate individual dry matter intake. Intake is affected by a series of factors, including parity. Here in this graph, we are able to see a clear difference in intake along lactation between multiparous and primiparous cows. Primiparous cows have a different behavior when eating when compared with multiparous cows. Primiparous are thought to eat more slowly, have a greater time necessary to masticate feed. They also spend more time eating, and they visit the feeder more frequently. In this scenario, we propose the use of accelerometers. Accelerometers are able to detect the acceleration in the three axes, Z, X, and Y, and they have been used in dairy research to estimate lying, rumination, and feeding behavior. However, studies mostly have correlated the time the cows spend eating in the 24 hours of the day. In 2019, Carpinelli and others were able to predict actual dry matter intake using accelerometers. The objective of this study was to evaluate the use of three-dimensional accelerometer sensors to estimate difference in dry matter intake between primiparous and multiparous lactating dairy cows. Beginning with materials and methods, our experimental design for the mid to late lactation hosting dairy cows enrolling in our study being 20 primiparous and 20 multiparous. Cows were housed in a freestyle barn, and they were trained for 1 week to use the column gate feeding system. Following training, animals enrolled in the study for 9 days, in which we collected accelerometers and dry matter intake data. Cows were fitted with 3 accelerometers in the jaw, nose, and rear left leg. Those accelerometers were set to record every 10 seconds throughout the experiment. In addition, we performed the video recording, and we were able to analyze 5 primiparous and 5 multiparous cows. We evaluated the feeding behavior of the animals for every minute of the day. If the cow remained inside the column gate for more than 50 seconds of that minute, we gave a score of 1. On the other hand, if the cow remained inside the column gate for less than 50 seconds of the minute, we gave a score of 0. That helped us understand the time points in which the cows were eating in the day. With this video analysis, we increased the data set used for Carpinelli experiment. Cows were then assigned into 2 groups. Each group contained 10 primiparous and 10 multiparous cows. The first group was the calibration group, and then the second group was the validation group. In the calibration group, we evaluated the acceleration variables highly associated with intake. Following that, we selected candidate model based on the difference in the actual intake and the intake estimated through acceleration. Following that, we used the validation group to estimate dry matter intake from the acceleration models to create the dry matter intake ACEL variable. Finally, we evaluated the parity difference in dry matter intake estimated through accelerometers. For the statistical analysis, we used the PROC-REC of SAS on the calibration group. Then we generated an intercept and a slope that was used on the validation group. We derived dry matter intake from the acceleration models to create the dry matter intake ACEL variable. PROC mix of SAS was used to confirm parity difference in dry matter intake. Statistical significance was declared at p-values lower than 0.05 and tendency at p-value lower than 0.10. Beginning with results and discussions, for the calibration groups, we analyzed the acceleration variables highly associated with dry matter intake. Besides the acceleration on the three axes for each accelerometer, we created new variables based on the difference in acceleration between two consecutive time points. These variables are very useful in estimating intake because, as we can see in this picture, when a cow goes from this position to this position, this movement is commonly observed when cows are eating. Following the analysis of acceleration variables, we created different acceleration models. We selected 4 potential models in which 2 presented the highest correlation between actual and estimated dry matter intake, and 2 models presented the highest dry matter intake type and time interaction. In the validation group, here we have the results of the actual dry matter intake. As we expected, there is a clear difference in intake between primiparous and multiparous cows. While primiparous cows ate around 23 kilos of dry matter intake, multiparous cows ate around 28, a clear difference of 5 kilos a day. This difference remained along the experimental period. For the dry matter intake based on acceleration models, models 1 and 2 were able to capture this difference in intake between the parities. However, we observe an overestimation of primiparous and an underestimation of multiparous intake. In these graphs, we can observe the results in actual and estimated dry matter intake based on model 1 compared with the actual dry matter intake. The difference between the groups is around 1.4 kilos a day, which is lower than the actual 5 kilo difference. The same pattern can observe for model number 2, in which the difference between groups is around 1 kilo a day. The same can be observed for model 3. Here we have a difference of 2.2. And model 4, which the difference is 1.7 a day. Regardless of the model, we were able to see a numerical greater intake from multiparous cows, and the estimated intakes were able to somewhat follow the variations along the time in the actual intake, as we can observe in these graphs. In conclusion, from the acceleration models proposed in our study, models 1 and 2 were able to assess the difference in dry matter intake among parity groups. However, we observe an underestimation of multiparous and an overestimation of primiparous cows intake. As future perspective, we aim to increase our data based on video analysis, especially for primiparous cows. We aim to increase the correlation and similarity of the actual intake with the intake estimated through acceleration. Future models can account for parity by including correction factor created by our algorithm. In conclusion, our results suggest a greater potential of using accelerometer sensors to estimate feed intake in primiparous and multiparous dairy cows. Finally, I'd like to thank the South Dakota State University and my lab team for the incredible help and opportunity. I'll be glad to be answering your questions. Thank you very much for your attention.